joining the webinar today, and hello everybody. My name is Sudhir Kulkarni. I am the CTO of SellPoint. I'm going to first discuss what is SellPoint, so just to give you a background of what we do as a company, so to sort of set up the perspective, and then get deeper and deeper into how we use the cloud and how we use Carvo to manage our business here. At SellPoint, we work closely with electronics manufacturers like Panasonic and Canon to create rich media product tours, and we create those rich media product tours in our asset management system. After we create those product tours, which includes video, PDFs, multiple pictures, 360s, etc., we syndicate those rich media product tours to different e-commerce websites like Walmart and Amazon themselves. Walmart, Sears, and Amazon, as you see some of the providers on the right here. Can we go to the next slide, please? So this is a quick picture of a high-level architecture of how SellPoint actually works. So in the cloud, we have a syndication engine that is deployed. And back in the private hosting, we have the asset management system, which we call as the merchandiser. So that's our merchandiser platform. So Active Product Tour is actually created in the private hosting. Then it gets pushed over to the cloud, which runs the syndication engine, which actually gets syndicated to about 160 retail sites. Can we go to the next slide, please? So here we talk a little bit about the Active Product Tours and the syndication engine and the SellPoint dashboard. One important thing I like to mention is when the tours run out there in the cloud, what actually happens is they collect the information about how long a particular tour is running. And that information is passed back into the private hosting from the cloud, and we create a dashboard of all that information. In this slide, I'm going to speak a little bit in detail about what the SellPoint infrastructure actually is. So here you see the graph that gives you sort of an idea of the number of what we call as number of engagements and number of minutes. So if you look at the graph, we actually, if you start looking from somewhere in the middle of the graph, we start building traffic up as the third and the fourth quarter for a given retailer because we are electronics e-commerce shopping engine. We start building up the traffic as we approach the fourth quarter. And as you can see, during the fourth quarter, we actually peak. And then you see almost a cliff as the shopping season ends. So we are almost like an ideal use case for a cloud in itself. I mean, the elastic computing cloud fits us exactly. Because if we have to build a fixed cost capacity, what Jamal talked about, we will have to invest about 60% more in fixed cost if you include the machines and the bandwidth and the whole management piece of it. And today we are able to save about 60% because we do not actually incur the cost throughout the year of our peak capacity. Can we get the next bullet, not the next slide? So just to give you an idea, we get about 4 million hits a day from many different websites. From about 160 websites, we get about 4 million hits a day. And we transfer video data. Most of the largest portion of the data is actually video data, about 8 terabytes a month. And all this is from S3. So all the hits come to the cloud, and all of the hits actually all the data gets transferred out of S3. Just to give you a brief idea of what SellPoint is. SellPoint is a proprietary SaaS application. It's software as a service. It purely runs on Apache and Tomcat. So we are completely open source. We built everything in Java, and we only use Apache and Tomcat. One important point here is the database, the information that is stored. We use Oracle currently, and that is actually in private hosting. So we do not use the database features of the cloud. When we decided to move to cloud, we were not on the cloud, obviously. And about 2 years ago, so you can imagine, so I think the people from Amazon will feel our pain because we were definitely one of the trailblazers. We went live on the cloud about 2 years ago. And that time, cloud was a new thing. It was really up there in the cloud. And we were very bold to actually take that step. When we decided to go to the cloud, we had to re-architect our application. At that time, what we decided was to sort of bifurcate our application, sort of break that in the middle. And what we decided was to basically have the confidential piece of the application continue to run in the private hosting environment, but the data that is on the public domain, we decided to run that portion of the application in the public domain or on the cloud. So we have a classical hybrid architecture. We do not run 100% in the cloud. We run partly in private hosting and partly in the cloud. So about once an hour or 10 times a day during the full business hours, we actually push the data that gets generated. So when these tools get created, we generate a lot of data and metadata. We take that data and we push that data 10 times a day or on every hour into the cloud. So the key point here is each instance on the cloud is self-sufficient. And we architected it this way to avoid the WAN interconnectivity issues. So when an instance is running and serving up these tools or the rich media, it never contacts back into the private hosting. It is self-sufficient and it serves the entire thing through the cloud. Can we go to the next slide, please? So after discussing some of the infrastructure, in this slide, I basically discuss some of the parameters and why we decided to choose the cloud and why we decided to go with Kavo. So like I said in the previous slide, the most important thing for us is the capacity management. We fully utilize the cloud's feature of capacity management. We scale up and scale down. We constantly monitor the load and our traffic. So we constantly look at load versus the traffic, and we decide how many more instances that we need. So our capacity and our demand is affected by three different things. The first thing I discussed already, which is the holiday shopping. We absolutely peak in Q4 and we hit a cliff on Q1. Because right now we are building up, as we speak, we are actually building up the traffic as we are approaching the busiest day of the shopping, which is Black Friday. So after Black Friday, we sort of continue that, we plateau that traffic right through Christmas, and then we cliff. When we get new manufacturer clients, for example, we landed Logitech very recently. Large number of active product tools get created and get syndicated through our syndication engine. As a result, we start getting large number of hits on our system. And the third parameter for our demand is the new products. So right around Q3 of the year, most of the consumer electronics manufacturers start getting ready and start releasing new products for the holiday shopping season. So these are the three sort of parameters that we have to manage while we try to manage the demand. And of course, like everyone else, as a CTO, I'm continuously under pressure to keep the cost down. So the model of basically pay for usage really works well for us. And like I mentioned before, and Jamal also touched upon this, if we have to do this in a private hosting environment, I will have to incur about 60% more cost. I also like to touch upon the IT team size. I'm also able to manage the entire hosting with much less IT team size as I might have required if I would be doing the private hosting. And some part of the management of the cloud servers especially is actually owned by my engineers as opposed to my IT staff. So one other thing that the cloud does for me is it actually empowers my full-time developers to actually manage. So the application that they build is more resource aware as it would have been to the private hosting. I already touched upon this, which is 60% fixed cost saving by leveraging elasticity. One of the most important parameters for me as we manage our business here is the time to market. as I touched upon before, we syndicate our tools to 160 retail sites. So all these retailers have very minor customizations. Most of them have minor customizations, and some of them have some major customizations that I need to basically cater to. So when I have to cater to these customizations, it involves the entire QA cycle. First, there is development, there is go live, and there is QA. And each one of these websites have their own go live schedules. So you can imagine the Gantt chart. It's absolutely crazy to manage their schedules and match up their schedules with my customizations and my team schedules. So I need sandbox environments for each one of them to do the testing before we go live. And if I have to go into a fixed or private hosting kind of environment, so what we currently do is we quickly go and grab an instance, do some quick testing, and then relinquish that server back into the cloud. So we do use that to sort of match up our time to market. And as a result, I'm able to handle my rapid releases and quick change management. I touched upon security a little bit in my first slide, which is what we have sort of taken is a sort of a shortcut into the security for the cloud. What we have done is we put only the data that is in public domain on the cloud, but the confidential data or the proprietary data is still in private hosting for us. So we have lots of private or confidential data like pre-release information and such from different CE manufacturers, consumer electronics manufacturers that we work with. But we do not release that data into the cloud. We control the push until that data is available in public domain. We start syndicating tools only when the data is available in the public domain. The next parameter for me is the reliability. So we significantly leverage the cloud to factor in the reliability aspect. What we do is we tend to run our servers at about between 60 and 65% of the load, and we build redundancy within the cloud to start with. So within the Amazon EC2 environment, my instances never run more than about 65% of the load. So if a server particularly fails, I of course get immediately notified, and Kavo immediately comes into play, and we get notifications at different hierarchies. But I get sufficient time to actually get a new server and put that in the pool. That is within the cloud. What we have also leveraged is between cloud to cloud. So we have another cloud that we parallelly run into. So if we would have a catastrophic failure on the Amazon cloud, we can very easily fail over to another cloud. In the second cloud, we do run on hot basis. The servers are hot, which means they are taking load along with the Amazon load. But large part of the load is taken by the Amazon, but the servers run hot, which means there is minimal interruption of service even in the event of a catastrophic failure on the Amazon cloud. And for the runtime management and monitoring, we use two tools. We use Kavo, and along with that, we use some of the open source tools like Captime. So with that, I think I come to the end of the presentation, and we would be happy to take any questions that you may have.
Here, thank you very much for that valuable presentation, Jamal, also for presenting and sharing all the great work that Kavo is doing with AWS in the cloud. We'll go ahead and transition over now to the questions and answers. We do have some very good questions that have come in. The first couple questions are targeted at Sahir. First question for Sahir is, given all the parameters that you mentioned, what is the number one reason why you have chosen to use the cloud?
That's a really good question. The number one reason I would attribute to the elasticity of the cloud. The capacity management of the cloud and the elasticity of the cloud was the most attractive thing for us, and because of which we went to the cloud, which gave us the benefit of keeping our fixed costs down. So since we are a seasonal business and we are sort of a company on the ramp, we get new customers our customers lease new products, and we have seasonal business. Because of these three things, we need the elasticity. And I'll have to continuously keep building my fixed cost up or my private hosting up. And that's the reason we decided to go with the cloud.
Very good. Thank you. And the next question is related to security, and I'll have both Jamal and Sahir answer this. And we talked a little bit about security in a few of the slides, and Sahir, you did a very good job of kind of explaining the hybrid cloud model. Can you elaborate more on how you secure the cloud, or how security is actually done in the cloud? Sahir, we'll start with you, and then Jamal, we'd like to hear your perspectives as well.
Yeah, sure. So, like I mentioned before, what we have done is most of the data that we have in the cloud is actually public domain. So data security is sort of not an issue for us because we have less incentive for somebody to actually hack into the cloud, because the data we have in the cloud is all available on the public domain. But we use standard tools and technologies to basically guard against different types of attacks, like ping attacks and hacking attacks, in terms of user authentication security.
Very good. Jamal, do you want to expand on that?
Yeah, I think I just want to, because I think Sudhir went out, part of it is like, also in case of Sudhir, what they have, the reason they chose only public, their data in the cloud is they also have a push from their customers, because there's a, cloud security is more of a perception issue, because people do have this feeling that, if something is out, it may not be secure. But we have customers who do use secure data in the cloud as well. And when you're going to cloud, there are standard best practices that are available to secure the data in the cloud. So, for example, if you are transferring anything between your data center and the cloud, the technologies are there to have a secure connectivity between your data center and the cloud. There is also, on the servers that are running in the cloud, you can have, via antivirus program, you also have firewalls and all those other things that are available to you. Even like Amazon provides firewalls that you can configure properly based on best practices to secure your servers. And then on top of it, that any data that you create in the cloud, there are tools available to encrypt that data. I mean, in Kavo, for example, we provide a way to encrypt data in the cloud on the disk that is you are generating in EC2 using AES 256-bit encryption. And AES 256-bit encryption is approved by NSA, National Security Association, for even top secret data. So I think from a security perspective and from PCI, there are applications that people are running in the cloud which are PCI compliant and HIPAA compliant. So it's more of less of a technical issue and is more of a perception issue, because like I was using the example earlier, that we can take the analogy of the banking industry, that we are the first bankers out there trying to convince people that, hey, it's safer to put your money in the bank than try to keep it in your own house. Because when you're going to a larger institution like Amazon or there is an expertise that you get, and you get an infrastructure to secure things much more efficiently and address problems much more quickly than you could do that in-house. Because if your data center come under attack, you will be more vulnerable than because you may not have all the expertise that a larger player can provide. So I think this is something that people will over the time realize, and so gradually will move towards running more secure applications in the cloud.
Well, thank you. We have another really good question that came in from the audience regarding total cost of ownership. Jamal and Sahir, you both addressed some of the cost savings aspects of your deployment in the cloud. Can you expand on exactly how you're calculating total cost of ownership and some of those actual cost savings that you've realized? So here, let's start with you.
Yeah, absolutely. So let's go down the list of at least at a high level, what are the costs that we incur. Let's start with the server cost. So one of the fixed costs is, of course, the servers. So the server cost, if I have to, like I mentioned before, we hit a peak around, say, November 24th or something, on the third week or fourth week of November during the Black Friday. And we continue that plateau through the month of December. And that, if you look at the full duty cycle of my utilization That is about, I would say, 50% of the fixed cost, incremental fixed cost that I will have to probably maintain to support that much load and the bandwidth. So there's a straight saving in terms of pure hardware. There is a straight saving of about 50% and the bandwidth for me. Then let's go to the next one, which is provisioning. So as the business expands, I need to actually procure, I need to cost compare, procure, provision. That cost is close to zero for me, especially because I use Kavo right now. So since I have a proprietary application, we have two identities created using Kavo. One identity is for the server, and the second identity is for the load balancer, because we use multiple load balancer and a bank of load balancers behind which we use a bank of servers. So we have basically two distinct identities. So if I have to actually procure, provision, and deploy, that whole cycle is shortened down to a matter of single-digit minutes using the cloud. And as all of us have, I think, the experience, it would be a matter of days. So there is a significant savings in terms of the manpower cost and time to market for me. And the third one is the manpower, which is if I have to actually provision, maintain, monitor these servers, I would at least incur 30% more in terms of manpower cost, which today I'm able to leverage some of the cycles from my developers themselves to do some of these tasks. And especially after automation of using a tool like Kavo, I'm further able to reduce that cost. So that's how I sort of calculate my cost. Jamal, you want to add more?
I think actually you have done a fantastic job. I don't have anything else to add to it. I think this is a great summary.
Great, thank you. The next question we have, Sudhir, we'll start with you. It's basically asking, once content is released via, say, a website like Walmart, how do you control the use of that? And how do you prevent any potential attacks on the integrity of that content, security of that content?
So we do it from multiple ways. So when we actually syndicate to a site like Walmart, we do have built in, first of all, features called domain security. So if that integration is compromised, because that integration is available on the internet, we would immediately know, and there'd be no content shipped, because we do a domain security check. We make sure that domain, only certain domains are calling us. Those are those 4 million hits that we talk about, which is before we serve up content, we need to get a confirmed hit from a secure domain. And if we do not receive that hit, we do not serve up the content. That's part of our syndicated engine security built-in procedure. That's also because multiple of our manufacturers, as you're aware, want to control their content going to certain domains and not going to certain domains, because they are sort of touchy about the gray market products that get shipped out. So that is one of the ways we control it. We also continuously monitor through the cloud. We have another infrastructure piece which I did not cover. We also continuously monitor where and how we are syndicating through 2 other instances in the cloud. So we do continuously monitor our own content through different instances in the cloud, and as the traffic picks up, we expand on that monitoring as well. So we know exactly where we are syndicating and who is actually leveraging our syndication. So if there is a misuse, we would immediately come to know about that.
Very good, sir. Thank you very much. Another question from the audience, I think a bit of an architecture question that I think SailPoint and Kavo could address, is the question is explicitly asked, how do you deposit and retrieve data to and from the cloud? So if you could talk a little bit about some of your strategies and your architecture regarding how you're doing data transfer in and out.
Yeah, that's an excellent question. That's a really good question, because this is the crux of our hybrid architecture. And if this portion would not work well, we would have a catastrophic failure. So this is currently completely proprietary architecture, wherein at set times in the day, we actually sync the data. We sync incremental data from private hosting to the public cloud, and then we bring the data back from the public hosting to back to our private hosting to create the dashboard data. So of course we have a fatter pipe going from private hosting to the public cloud because we transfer rich assets, whereas we only transfer text data from the public cloud to the private hosting.
Very good. Jamal, did you have any comments regarding architecture or data transfer?
I think the data transfer is basically, it comes down to what we have seen is like how you're understanding how much data you need to transfer and what your SLAs are. Because then you have to work, most of these, the cloud, Amazon, for example, provide peering points. So if you have a large amount of data, you can have a private connectivity between your data center and Amazon through that peering point and be able to get like right SLAs and right bandwidth. So I think from data perspective, the most important thing to consider is what is important for you. Is it bandwidth? Is it latency? Within the US, we have not noticed any latency issues in running applications in our private versus private data centers and cloud. But we do have noticed that bandwidth is a big issue, and that is something that you have to look at what level of data you are doing. For example, one of the customers we were speaking to, they want to transfer 1.2 terabytes of data on a daily basis, and they want to do it on a pipe. So you just need to make sure you are using a bigger pipe, and that bigger pipe is available. You just have to pay a little bit more for it. So I'm not sure if I addressed that question or if that was the context of the question.
No, very good. The next question, and Jamal will let you kind of expand on this, and to hear, it'd be great to hear your perspectives as well. Can you elaborate a little bit more on how Cabo is adding value on top of AWS infrastructure services? And Jamal, I'll let you start with that, and so here it might be good for you to follow up with the second part of the answer, explaining why you've chosen Cabo as a part of your solution.
So I think if you look at what Amazon is doing is a great job in providing the resources on demand. So when you get the resource, you get a base server, but anytime you have to run an application, or you need to make sure that server is properly configured in the context of your application, all the software is deployed, and not only all the software is deployed, but when the server comes up, all the services are started in the right order. And if you're dealing with a complex system where you may not have just one server where you just launch the image and everything comes up, you may have dependencies. So for example, if you want to bring up a 3-tier system with a database tier, app tier, web tier, you need to bring these servers in order, and you have to make sure they are properly configured. So the value Cabo provides is, the core value is to provide the automation in terms of deployment. We have a sophisticated workflow and provisioning engine which allows you to set up dependencies that bring up my database tier first, then my app tier, then my load balancer. And it tells you very transparently from a top-down application owner perspective how the servers are coming up, how they're getting configured. And also when you're, for example, adding up, scaling up a MySQL cluster, or if you're scaling up a JBoss cluster. In both cases, when you add a new resource to the cluster, you need to configure it and make sure that it's configured in the context of your application. All your firewall security roles are properly configured. So those are the things that we automate fully. So you don't have to do anything manually. Because, there is no point of getting a server in 2 minutes if you spend 2 days in configuring it. So the idea is if you're getting a server in 2 minutes, it should be configured in 2 minutes also, so you're ready to use it. So that's the value we are providing, and not only that, but when you're doing runtime, we provide what we call an autopilot capability, where during the runtime, most of the time, based on my experience in managing infrastructure before and mission critical applications with larger organizations, is that most of the time when you have outage, there are known issues. People know that, okay, this application has a memory leak, you have to restart a web server, or when the batch job doesn't run, you get this error. So when there are known errors, we have this event to action mapping where you can define custom complex workflows to take place whenever those known event happens. So, for example, if there is a process that needs to be restarted, whenever that events happen, our engine will automatically go and take that process. So you get a ease of use during runtime management. So that's the value that we are providing on top of Amazon to make it easy to deploy and manage applications. And we are looking at everything from application owner perspective. Sudhir, you can really elaborate more on how you are using it or what's the biggest benefit you are seeing.
Yeah, absolutely. So just to remind what the question was, what exactly is the value that tools like Kavo or Kavo in particular provide on top of the AWS? So when we started using Amazon, what happened was we actually got the raw instance. So what the raw instance actually gives you is it eases your pain of cost comparison, procurement, provisioning. But what it does not provide you is that server, actually after that, you have to do a set of manual steps or build a set of scripts to automate to get to a point where that server now can start taking load or becomes part of the pool. So what the value that Kavo provides, especially for someone like us, who have absolutely proprietary application and proprietary deployment, and we also have a sequence of deployment. To make a server part of the pool, we need to deploy software in a certain way and do some quick smoke testing to make sure that server is now ready to take the load. We can actually configure all of those steps in Kavo, and in a single button press, we have a server now ready to take the load. So that is the biggest benefit for us from Kavo.
No, thank you very much. We still have a lot of really good questions coming in. I think we have time to answer one more for both Jamal and Sudhir. Sudhir, this is probably first really directed at you. In terms of, we talked a little bit about security, but the question is really around legal considerations in terms of the type of data that you're working with in the cloud. And I suspect that the questioner would like to know a little bit more about privacy considerations as well, since you are dealing with customer data, and there may be some legal or security and privacy ramifications. Can you elaborate a little bit on that in terms of your policy and how you've approached that?
Yeah, so our policy, we have tried to keep our policy very simple, which is we do not push or share any kind of pre-release data or customer confidential information onto the cloud unless it gets into a sort of a public domain type of information. So we try and control that through domain security and through what we call as our push architecture, where we push the data between the private hosting and the public hosting. So we do not syndicate or even push the data. So the data is unavailable. It's still behind the firewall until the data becomes sort of into public domain.
Very good. Thank you. And we have one final question that we won't be able to expand on in great detail. I'd like to point out that on the Amazon Web Services Solution Provider Program website, we are building a content page related specifically to the licensing of third-party applications on AWS. As you might imagine, there are several models. Software as a service model, there's pay-as-you-go, there's bring your own license. There's a whole blend of licensing models that various ISVs like Kavo are deploying so that you can use the software that you're used to on-premise in the cloud. I probably would like to turn that over to Jamal. Jamal, can you talk a little bit about Kavo's licensing model as it relates to SaaS, as it relates to bring your own license or pay-as-you-go, and then we'll wrap up.
So I think like there are two things. What Kavo is providing the way to automate the deployment management, but we assume that the customers are going to bring their own license. Or in some cases, Amazon already provide the licenses, or they're like the AMIs, for example, for Windows and others that are available from third parties, which already have the license cost included as a part of the instance. But in our case, what we ask for customers is to provide the license for the software they want to run in the cloud. In terms of for Kavo, our application itself is delivered as a SaaS application, so it's a service, and it's a purely pay-as-you-go model. So for using Kavo, you just pay on a monthly basis for the usage. But for the software that you're running, you have to provide the licenses for that software.
presentation. And with that, we will close our Q&A session, and we would like to thank all the attendees again for taking time out of their busy schedules to join us today. You will be receiving a follow-up email from the Cabo team with a link to the archived recorded webinar and some other valuable resources to you, so you may consider Cabo and AWS for your future solutions. Again, thank you very much for joining the webinar, and we wish you all a very pleasant day.